Hello, this is EAS 3800. This is lab group 5. This is for our final project. My name is Matthew Livengood, and I'll be covering the goals and design requirements. So the goals of this experiment were to use an Arduino system and various specialized modules to measure temperature, distance, and depth. After the data was gathered, there was statistical analysis performed on the data, and also calibration was performed to reach a specific resolution level. And we found this to be very important in further experiments because you can use this technique to narrow down the resolution and achieve more accurate results.
Our initial our initial plan was to just go through the lessons, build the assemblies, and acquire and interpolate that data. Oh, I'm Kevin B. By the way, sorry. And then how it actually went down was we went through the lessons, we built the assemblies, and then we used third-party resources to troubleshoot the code. And then acquired that data and then realized we need to calibrate it, and then got some additional data which we actually used. And then Aaron Pomeray is going to go through the design.
We started with modifying the code for the lessons in order to account for using a servo as the depth and distance gauge. We then modified the wiring with the Arduino to account for the servo gauges on the depth and distance measurements. And for both the water level and distance measurements, the wiring stayed the same except for the 5-volt power and ground power were run through a breadboard to allow for the servo connection. The 12-pin LCD thermometers wiring and code were pretty much the same as the provided lesson. And the most egregious problem was the Arduino program kept choosing the wrong communication port to upload the code through. This resulted in the code not being uploaded properly. However, it had a simple fix, only had to change a few settings within the device manager. Other issues were slight syntax errors, and as was previously stated, it was fixed using third-party resources. Mainly for calibration, for the depth sensor, we had measured depth check marks with a ruler and changed the water level accordingly. We had the sensor statically attached to a cup and recorded the servo gauge's readouts. We did the same for the distance, but rather changed the distance at known intervals from a wall based off of a ruler and recorded the servo gauge's data. The thermoresistor data was collected via an LCD panel, and comparing those results with a mercury thermometer, bringing the two to different locations and different times to measure different temperatures, and recorded the results. Thank you for listening. Up next is my partner, Victor Santiago.
I'm Victor Santiago, and I'll be going over the significance portion of this experiment. So the Arduino software and its many components are an easy tool for beginners. They can introduce them into circuits and the use of sensors in order to collect data. Having this in mind, as an objective of this project, the calibration of these systems was to be achieved. And this is an important part, as data collection and analysis is what drives innovation. As we explained in our report, the methodologies and sensors used in this project can be further scaled. As an example, the water level sensor can constantly inform us of the condition of a fluid system that needs to be above a certain threshold. The temperature sensor can be implemented in agriculture as a method to study soil temperature conditions, and the distance sensor can be implemented in autonomous devices that rely on obstacle detection. With this in mind, I conclude this presentation, and thank you for your time.